Hello and welcome to class number 13, which is going to cover section 7.1 and 7.2 in benefit cost analysis chapter. And I will again refer you to the schedule of assignments in the Start Here page of Blackboard. The schedule of assignments now includes the entire semester and the due dates for all the assignments. For example, this chapter 7 homework will be due on October the 11th, and this is the week of October the 6th that this chapter is due to be mastered by you, the students. I again refer you to the bottom of the start page in Blackboard to keep abreast of what the due dates are and what is assigned and so on. You should read pages 196 to 205 in the ebook, Smart Book, regarding benefit cost analysis. Usually we designate that as B/C or BCA. The B/C is basically the ratio of either the present worth or the annual worth or the future worth of the benefits divided by the present worth, annual worth, or future worth of the cost. Normally, probably the most common is to use the annual worths because we have a lot of data given as annual data. But other times we use present worths, not so much future worth, but it is possible that you could. It doesn't matter which one of the three you use. You get the same ratio if you do it right, okay? So this instructor video will be posted on Blackboard, and of course you can view it on YouTube as well. The last thing I want to do is mention that this is, we're covering sections 7.1, 7.2 again. And the video lecture may not cover all the notes. Usually I do, but if I don't, you're still responsible for all the notes. Of course, you're responsible for the reading assignments, the problems at the end of the chapter, and but what you're going to be graded on is the homework assignments. They will be graded automatically in Blackboard, which is connected to McGraw-Hill's Connect learning management system. If you want to make a good grade in the course, work as many problems at the back of the chapter as you can. End of chapter problems, I call them. This chapter, or this method we call benefit cost analysis, is the public sector's version of rate of return or present worth analysis. In other words, in the public sector, they're generally the projects undertaken very often do not include revenue. So rather than being able to do a rate of return on the net cash flow, we look at the benefits to the public and the cost to the government. Now, when we think about the public, they're really the owners of the public sector projects. And when we talk about public sector projects, we're talking about government projects at the federal, state, or local level. We could also be talking about government agencies, such as the highway department or the housing department of these various levels of government, the federal, state, or local. So benefit cost analysis is used for government type projects that are not private sector projects. And the public sector projects differ from private sector projects in a couple of ways. One is that very often, especially if they're federal projects, the public sector project is much larger. For example, building an interstate highway system was a public sector project of the 1950s and a federal project, and it has benefited the entire public of the United States in one way or another for the last 50, 60 years or more. That would have been considered a very big project, but most public projects are big as compared to a private sector project, which, for example, might include whether or not to repair a pump or replace a pump. That would be relatively small compared to the interstate project highway system. So in the public sector projects, another factor that's different generally from private sector projects is the interest rate is much lower, generally speaking, because there's no profit motive, number one, and also public sector entities do not have to pay taxes, so you don't have to make enough money to not only pay the interest on loans, but you pay it at a lower rate because the interest rates are lower because you don't pay taxes. And so this has ended up creating, so to speak, a market or a need for what we call public-private partnerships, where the public entity can borrow money at a much lower rate because they don't have to pay taxes. And also, if you talk about municipal projects, that is city-type projects, the bonds that they issue to finance these projects, which are basically loans, the bondholders don't have to pay interest on the dividends on municipal projects, generally speaking. So all of those things have an influence on reducing the interest rate and sometimes extending the length of the project. Typical local projects might be local highways. For example, Major Drive in Beaumont could be considered a local highway project. Hospitals, our hospitals are privately owned by nonprofit organizations, generally speaking. Not all of the hospitals, but for example, Baptist Hospital or St. Elizabeth's Hospital are owned by basically religious organizations that are nonprofits. Universities, sports arenas, Dallas Cowboys Stadium or the Houston Texans Stadium were built with government agencies, so to speak, and so money. Some cities, for example, the city of Austin, Texas, has a private utility, whereas we have a public utility, Entergy Corporation. They have a city-owned utility. So these public-private partnerships, for example, when you have a toll road, a private entity could be involved. Not always. Sometimes just the public entity that built the road collects the tolls. There may or may not be a private partner. So a number of areas are different. So funding public projects uses taxes, fees, and bonds, and gifts, but not, universities use gifts a lot, but the other things like highways and hospitals generally don't, but, well, hospitals do, MD Anderson gets significant gifts, and so on. Taxes, fees are collected from users, for example, toll roads, and so on. The interest rate is generally lower. The alternatives are selected. Sometimes in public sector projects, the alternative selected can be influenced by politics, whereas that's not so much the case in private sector. It's generally profit, a private company is interested in projects that will increase their profits. Whereas a public sector project may be influenced by how many votes it might influence, and so on. So politics does have an influence on public sector projects, even though we would hope it has a small influence, not a big one. That may not be the case either. So cost, expenditures to the government to build, maintain, and operate projects, salvage values, savings possible. So those are all things that are possible. Of course, savings are a negative cost. Okay, and then benefits, advantages to the public. So the costs are generally the cost to the government. The benefits are generally the benefits to the public. For example, if you build a city park, the benefit accrues to the people who use the park, which are citizens of that city, generally speaking. And then there's disbenefits. So I very often talk about net benefits, which is benefits minus disbenefits. Disbenefits are undesirable consequences of maybe a public sector project. So if you build a city park, that takes that land away from the private use, whereas you might be able to sell that piece of property, and the city might be able to sell it if they own it, and then reduce the tax rate of the citizens. So that would be a disbenefit by taking that out of the city's ownership, so to speak. So ethics come into play because in all of engineering, actually engineering is not just mathematics, it's also judgment. And anytime you have judgment involved, then ethics becomes a consideration. And so engineers have a code of ethics. We talked about it a bit in chapter 1 and of this course, and I just I summarized it very simply. I said, in a simple ethical code is don't cheat. Excuse me. Most cheating does not start with big amounts. Usually it's small amounts, and usually you can get away with small amounts of cheating in outside in the real world, so to speak. But what happens is small amounts lead to bigger amounts, and once big amounts of money get involved, somebody gets hurt and they want someone to pay for it, and they will make a big effort then to find the cheater. We have billionaires who've had to go to jail because they cheated. Why would someone that has that kind of financial resources be willing to risk their life, so to speak, by cheating? But they do. Don't do it. Don't start cheating small, and then you won't cheat big, and then you won't have to pay the consequences. Benefit cost analysis of a single project is our next section, section 7.2. And the basic benefit cost ratio is given by equation 7.1. And the first thing we have to do is decide, are we going to use present worths of the benefits and the cost, or are we going to use annual worths of the benefits and the cost, or are we going to use future worths? Now, the most common is usually annual worths because a lot of times the cost and the benefits are given on an annual basis, so much a year for so many years. And the basic equation then, whatever of these three elements you decide to convert all the benefits and all the costs to, that ratio, if it's greater than 1, then this project is economically acceptable. It doesn't mean that it'll be actually accepted. It just means that it's potentially acceptable, okay? Or it can be accepted. It doesn't mean it will be accepted. But if it's less than 0, if that ratio of say annual worth of benefits divided by annual worth, if that ratio is negative, it's rejected out of hand. It's not considered again. And so equation 2 says, well, sometimes those benefits come along with disbenefits. One segment of the population benefits from this thing that the public entity is thinking of doing, but another sector maybe experiences a disbenefit, or maybe even the same sector. So we get the net benefits in the numerator, present worth of net benefits or annual worth or whatever, and then the cost in the denominator. Sometimes the cost in the denominator include the initial investment costs, say to build a park, and they also include then the maintenance and operating cost of that entity. So that's equation 2. It just added the disbenefits in the numerator as a potential extra element. Now, there's another ratio that is called the modified benefit cost ratio. The modified benefit cost ratio is modified from this one in that this cost in the denominator of equations 1 and 2 could include both initial and maintenance and operating or annual cost, whereas in the modified method only the initial cost is in the denominator. If there are maintenance and operating costs, they're treated similar to a disbenefit in the numerator. In other words, they're subtracted from the benefits in the numerator. So that's another way. And whenever equation 1 and 2 are greater than 0, that ratio, equation 3 will be as well. So it changes the number of the ratio, but it doesn't change whether it's greater than or equal to 1. The last thing we'll cover before we work some example problems is the difference measure. Rather than doing the ratio of benefits divided by cost, we do benefits minus cost. Well, if benefits minus cost, if benefits are greater than the cost, the ratio will be greater than 1. If benefits are greater than cost, then this difference will be greater than 0. Okay, so that would be the guiding criterion for accepting if the difference B minus C is greater than 0. So those are that's kind of the equations that we'll use. The next thing I'm going to do is go to end of chapter problem, and I'm just going to work one problem in this session. It's problem 7.8 at the end of chapter 7. So problem 7.8 says, from the following data, use the conventional BC ratio for a project which has a 20-year life to determine if it is economically justified. Use an interest rate of 8% per year. So we're given the planning horizon. So we have n equals 20 years. and we're given the I that we're going to use. I is equal to 8% per year, and we are assuming compounded annually. And now we have some data. And here you have the consequences to the people. So you have annual benefits of $90,000 per year, and that's going to be for that 20-year period. And you have the annual disbursements of annual disbenefits, not disbursements, disbenefits of $10,000 per year. So that's a disbenefit. And these are both annualized, annual A series, okay? And then on the government side, you have a first cost of $750,000, and you have annual costs per year for these 20 years of $50,000. And you have annual savings of $30,000. So maybe this project is replacing some other project, and by replacing that other project, you're saving $30,000 a year. And so most of these data given are annualized, so I'm going to work with annual worth of benefits divided by annual worth of costs. So I want to find the annual worth of the benefits to start with. The annual worth of the benefits, well, we got $90,000 per year is a benefit, and then I minus the disbenefit, or this will be the net benefit of $10,000. So the annual worth of the benefits is $80,000 per year for years 1 through 20. Well, how about the annual worth of the cost then? Well, we have an initial cost of $750,000, and we need to spread that as an annualized number then over 20 years at 8%. So that would be $750,000. Find A given P at 8% for 20 years. And that would be dollars per year for 20 years. Plus we have a cost of $50,000 per year for 20 years. And then we have an annual savings. So I'm going to subtract that savings, $30,000 per year for 20 years. So all of this is per year for years 1 through 20. So let's do the calculations. If you plug in to the A given P equation for 8% for 20 years, this number comes out to be $76,000. $76,389. That's 750 times A given P, 8% for 20 years using the app on my cell phone. Then I'll net these out. You got a 50 plus 50 and a minus 30, so that's plus 20,000. And all of this is dollars per year for years 1 through 20. So when we add the 20 to the 76, we get $96,389 per year for years 1 through 20. And now we just have to calculate the ratio. Well, we have cost of $96,000 a year, and we have net benefits of $80,000. Doesn't look too good. So our BC ratio will be $80,000. That's dollars per year for 20 years, divided by $96,389. And that will be a ratio of 0.83, which is less than 1. So the project is not economically feasible. So we would not do that project. That's the solution to problem 7.8, and that concludes this video lecture. Thank you.